Let us first get an idea of difference table. Difference table of a tabular data. We know that if x and y are a set of data x0, x1, x2, x3, x4 and correspondingly y0, y1, y2, y3 and y4. Bivariate data, y depends on x, so we have a cluster of tuple points. x0 corresponds to y0, x1 corresponds to y1, x2 corresponds to y2, x3 corresponds to y3 and x4 corresponds to y4. Now from this tabular data we intend to find the difference table. A basic preliminary premise is that we assume that this is an equal difference table. That means each of these x node is separated equally or the increment is uniform. I hope you can follow. The initial point x0 has an increment h and we have x1, then x1 has an increment h and we get x2, and x2 has an increment h, we get x3, and x3 has an increment h, we get x4. So all these x0, x1, x2, x3, x4 are plotted with uniform increment, but obviously y0 is not so because y depends on x in different way, and our intention in polynomial interpolation is to find a polynomial which relates y to x. Okay, so first of all we would like to know what is a difference table. There are two types of differences. One is forward difference and another is backward difference. One is forward difference and another is backward difference. And it's quite easy to conceive that if we express the y nodal points as fx, obviously the forward difference, usually denoted by this capital delta, delta of fx, is nothing but the difference between fx plus h and fx. Isn't it so? Forward difference. The difference between fx plus h minus fx is represented as delta of fx. And similarly, in terms of backward difference, this same difference is denoted as nabla of fx. This is denoted by backward difference operator. So this is the forward difference operator del, and this is the backward difference operator nabla. Sorry, we should write it as nabla of fx plus h. So this difference in forward difference operator is represented as delta of fx. So the difference between fx plus h minus fx is actually delta of fx. And in terms of nabla, that is backward difference, it is represented as nabla of fx plus h. So with this preliminary concept, we move on to find the forward difference table first of this tabular data. So we calculate the difference between y1 and y0 and write it here. Similarly, we calculate the difference between these two and the difference between these two and the difference between these two, and it is quite reasonable to perceive that this is represented as delta y naught, because f of x plus h minus fx is delta y fx, delta fx. F of x plus h minus fx is represented as delta fx. So this is actually f of x0 plus h, isn't it so? y1, this is x0 plus h x1, and this is x0. So obviously it will be represented as delta of fx0 or delta of y0. And similarly this will be delta y1, this will be delta y2, and this will be delta y3. So this is the first difference of y. And now we will tend to write difference of first difference, which is nothing but delta y1, this is delta y1, isn't it so, minus delta y naught. So y2 minus y1 minus y1 minus y naught, and it becomes y2 minus 2y1 plus y naught, isn't it so? Similarly, we have here y3 minus 2y2 plus y1. Here we have this minus this, so y4 minus 2y3 plus y2. So this is as far as difference of first difference is concerned, that is denoted as second difference. Then we have third difference, which obviously is considered as difference of second difference, that means this minus this, which is written here. And if you subtract y2 minus 2y1 plus y naught from y3 minus 2y1 plus y1, we have y3 minus, just see, this is nothing but y3 minus 2y1, sorry, this is 2y2, I have erroneously written it as y1, y3 minus 2y2 plus y1. So if we subtract this minus this, it becomes y3 minus 3y2, isn't it so? Minus 2y2 minus y2, and this is plus y1, minus of minus 2y1, so this becomes plus of 3y1, isn't it so? And then we have minus y naught. We are just calculating y3 minus 2y2 plus y1 minus y2 plus 2y1 minus y naught, and this results y3 minus 3y2 plus 3y1 minus y naught. Similarly, you may note that y4 minus 2y3 plus y2 minus y3 plus 2y2 minus y1 gives us y4 minus 3y3 plus 3y2 minus y1, isn't it so? So these two values are actually third difference or difference of second difference, and we have two values, and the table ends here when we write the fourth difference, that is the difference of two third difference, and you don't have any other differences since we have 5 arguments here. Whenever you have n arguments here, the table, this is called diagonal difference table, it ends in n minus 1th difference. Quite obvious, because here we have 5 elements, and in first difference we have 4 elements, in the second difference we have 3 elements, in the third difference we have 2 elements, and in the fourth difference, which is the difference of third difference, we have only a single value. And now we intend to write this here, because we don't have space left in this small board, so we intend to write the difference between these two, difference of third difference, which is nothing but delta 4. What it becomes? Just note, let me write it in red ink and in bold face. Subtracting y4 minus 3y3 plus 3y2 minus y1 minus y3 plus 3y2 minus 3y1 plus y0, it gives y4 minus 3y3 minus y3 gives minus 4 y3, then plus 3y2 plus 3y2 gives 6 y2, then minus y1 minus 3y1 gives minus 4 y1, isn't it so? Minus y minus y, and then plus y naught. So this is the fourth difference of third difference. Now just have a look that this is nothing but 4C0, this is 4C1, this is 4C2, this is 4C3, and this is 4C4. Or you may think it like this: this is 4C4, this is 4C3, this is 4C2, this is 4C1, and this is 4C0. Isn't it so? And you can match it. In case of the third difference, we have here 3C3, here 3C2, here 3C1, and here 3C0. Here also we have 3C3, 3C2, 3C1, and 3C0. And that is why it is called symmetric difference table. Okay, we have a nice symmetry inherent when we take the difference of these arguments. Okay, and obviously you can rewrite this in terms of backward difference table when nabla y1 represents this. Y1 minus y0 is nothing but delta y0 and nabla y1 in terms of backward difference, isn't it so?